Hello and welcome back. In last lecture, I showed you how nitrogen nucleophile can react with a carbonyl in order to get you even a compound. The nitrogen that we used was a primary nitrogen. So we said we have an R attached to nitrogen and nitrogen carrying two hydrogens. And now I'm going to switch this one to R2, and that's going to leave us with only one hydrogen and nitrogen. And remember, in both cases, we have lone pairs sitting on nitrogen. Now, if you take a secondary nitrogen and react it with a carbonyl or aldehyde group, and you will get you might get one product that we call it enamine or enamine, and it depends whether you have a hydrogen sitting on carbon neighbor to the carbonyl group or not. Okay, and again, the reaction is going to happen in acidic condition. If you start with a primary nitrogen and you react it with aldehyde or ketone, you will have a double bond between nitrogen and carbon. Hydrogen, it has a positive charge there, and in order to stabilize it, we need to get rid of the hydrogen. Which hydrogen? The hydrogen that's sitting on nitrogen. Okay, so we are going after this hydrogen, and when we take the hydrogen out of the system, that's going to leave a lone pair of nitrogen, and we get a neutral compound, and that neutral compound, it has a double bond between carbon and nitrogen. We call it the imine. So we started from imine and we turned it to imine. Okay, so in imine, we have double bond between carbon and nitrogen. Okay, plus water. Now, if I replace this, the primary nitrogen, the nucleophile, and use a secondary nucleophile, and now react this one with aldehyde or ketone, it doesn't matter. In the presence of acid, again, we will have a species that has a double bond between carbon and nitrogen, and there is a positive charge. Let's highlight that bond. This is the bond I'm talking about. Now, nitrogen has a positive charge because we used the lone pair to actually attack nitrogen, the carbonyl group. And now we got we got also water out of the system, out of the system. We removed the water, and that one left us with a double bond between nitrogen and carbon. But there is a positive charge on nitrogen. How do you want to make it neutral? Nitrogen does not have any hydrogen anymore. So I can't take R group. I can take those R groups out of the system. And I need to look for another source. Now, is there any hydrogen attached to a neighbor carbon? And if there is a hydrogen there, then that hydrogen can be removed. And if we take that hydrogen out of the system, then we can share it with this carbon, and then we can move the lone pair, the double bond on nitrogen as a lone pair. So a difference between the primary and the secondary, and then the nitrogen nucleophile. And a secondary nucleophile, in order to stabilize nitrogen, we will take hydrogen from the alpha carbon, the carbon that is neighbor to the, like the carbon that used to be involved in carbonyl, technically bond. And well, in the primary, we took the hydrogen exactly from nitrogen, not like a carbon. And remember, nitrogen is more electronegative than carbon. Okay, so that means like the NH bond is going to be easier to break it versus the CH bond. Okay, again, we get water. And now what did we get? We got this. We got this bond. Okay, that's just simply an alkene. Okay, this is an alkene. Okay, and remember, in alkene, we said we take an alkane, replace it here, just simply replace the A by E, and that's going to leave us with alkene. So I got an alkene, and my alkene happened to have this group. I'm going to highlight it, NR2, and that's an amine. So what do I have? Okay, I have an imine, and also there is a double bond there. So I'm going to fix this, fix the naming by using this. I will use En for the double bond. And also, I want to say I'm dealing with an amine group. So I go A-M-I-N-E. So I'm dealing with an amine or an enamine. Okay, and that's gonna tell me that there is a double bond between two carbons, and one of the carbon is carrying, like a nitrogen with, say, two groups attached to it. Now let's go after the mechanism. Again, the mechanism is going to happen in acidic condition, and so it will be really copy paste of the previous, mechanism that we practice. I'm talking about the primary, except in close to the end, it will be a bit different. So the first step, we will have nitrogen attacking the carbonyl group, and that's going to give us oxygen with a negative charge and also nitrogen with a positive charge. We need to neutralize oxygen as soon as possible. So if we have an acidic H there, that's going to actually give it an H, and it will be neutralized. And what's the source of the base? It's the source of the acid here. Source of the acid, you can say I have this compound R2 and NH. In the presence of acid, this one is going to turn to R2, and then we get NH2, and it will be a plus. So this is going to be your conjugate acid, and it can donate H plus to the oxygen. And if we take H plus from it, of course, we're going to recover R2 and H, or the starting compound. And so this one happened, and now left us with nitrogen with a positive charge. We want to take the H from it, and the base, it can take it. Which base? This compound. I'm talking about this one. This one, it can go actually, and it can behave as an A, and it will take H from nitrogen with a positive charge. Now I got a compound that it has the amine group and also alcohol functional group at the same time. And so as you see, we have an OL, and then it's the alcohol, and also we have an amine, and at the same time. Now, if we add H plus to OH, that's going to turn into a good leaving group. So this one, it will be a good leaving group. And now that's a good leaving group. We can get it from nitrogen to kick water out of the system, and that's going to leave us with a double bond between carbon and nitrogen. Okay, now we have a double bond between nitrogen and carbon. Well, nitrogen is carrying also two R groups. You can take H from nitrogen in this case. And while in the previous, the previous mechanism or the primary, we said we can go after one of these H's, one of those, and in order to turn nitrogen to nitrogen zero or make it neutral. But in this case, we have R. It's not in hydrogen, so I can't kick R out of the system. And in this case, I will go after the neighbor hydrogen, okay, or neighbor carbon technically. Neighbor carbon, this is going to be the alpha carbon, and we will take hydrogen from the alpha carbon, and that's gonna help us to gain lone pair, and we share it with the neighbor carbon, and then the double bond we can give it to nitrogen in order to recover the lone pair on nitrogen. So the difference is here. This is the difference between the primary and the secondary nitrogen nucleophile. Okay. If you start with primary amine, again, the first step, it's going to be almost all the steps are identical, except the last step when we are, the one that I drew a circle around it. We get this species. Now we're going to take hydrogen from nitrogen, and that's going to leave us nitrogen with a lone pair sitting on it. So now it will be neutral, and I call it an amine. And in case of the secondary amine, I can't take, a hydrogen from this group anymore. That's not going to happen. And so in this case, you're going to zoom on one of these neighbor carbons, and those neighbor carbons, if they have hydrogen attached to them, you can take the hydrogen out of the system, and that's going to leave you with a double bond between the two carbons, these two carbons. And now what happened with the double bond that we had between nitrogen and carbon, that one showed up as a lone pair on nitrogen. So this is exactly the difference between amine and an amine or an amine. Okay. And we can use, nitrogen in a compound, dinitrogen actually in this case, and to reduce the alkene or aldehyde, functional groups. But that's going to be a good subject for another lecture. And thank you very much.